So just to present myself, I'm a product manager for IoT systems, and I'm in charge of systems and test chips. So that's why I will talk about this in this presentation. So I will start with our vision for IoT security, and well, maybe you have heard about that, but we'll recap a bit what we are doing in that area. Then our developments in security, and then talking about the Musca test chip program and what we do around this, and how we can collaborate with academics on this topic of security. So let's start with security. You have probably heard about that. We have launched a big effort to tackle security in IoT because we think it is important. And one of the major issues with security is that you can't add it in a later stage to a product. It needs to be built in from the start. And it's a complete chain. You can't really say, okay, this part is secure and forget about the rest. We need to implement security everywhere, and we need to make sure that it's simple to implement because, well, the companies who build IoT devices are likely to not be experts in security. And we need to reach a certain level where we have to encapsulate this expertise and make sure that everyone is able to implement a secure system. So following these observations, we launched last year the Platform Security Architecture, which is an initiative to make security more or less understood by everyone. And to do this, we partner with the industry. We don't do it alone because that's not a good way to progress. But we decided to partner with security experts, with the industry, to make sure that we define what are the best practices, also to explain how to analyze the threats that apply to devices and well, really understand exactly what is necessary to do to counter the threats, and also provide elements that can allow to implement security in IoT devices. So this effort is still ongoing. We have started to release some threat profiles that will be used for some types of IoT devices, but it will continue, and we should announce new progress next month. So this effort, we partner with experts. So if you are experts in security, that's a good collaboration point. Now, on our side, of course, we also try to provide elements that can be used to implement security in IoT devices, and that's the topic of this part. Here you see on the diagram there are several types of threats or several types of vulnerabilities that can apply to IoT devices, from the communication vulnerabilities where you want to make sure that your communication link is secure. In that case, we have developed blocks that can handle cryptography and protect this link, well, or can accelerate some operations like accelerating TLS, for example. But there are also lifecycle security, where we need to make sure that we control the life of the product and make sure that we can't attack the product using that type of attacks. Of course, software security is a big topic where we need to isolate different elements in the software stack and make sure that, well, software that is not trusted cannot disrupt the basic function of the IoT devices. So for this, we have, of course, the TrustZone technology, but we also have blocks like Secure Enclave, which is called CryptoCell in our case. And finally, physical security is trying to protect against tampering attempts. And here it's for obviously not all the devices, but some devices are really critical in that area. And here we can reuse elements like secure cores, which are processes that are targeting, up to now have been targeting mostly smart card market, but they can be reused in IoT contexts, etc. The other thing we do to help with security is also to pre-integrate systems. And that's something that is done in my team, and that is really helping our partners going well, faster when they implement these designs, when they implement IoT systems. But also, we pre-integrate in these platforms, we pre-integrate the security features that will help them to get a strong foundation. It's not the end of the design, so they have to do things in addition to that, but it's a good start. And these subsystems are products that we provide to our partners to help them to build their systems. On these systems, we develop software as well, and this is interesting because, as I've explained, there are a lot of elements that need to be put in place to get a security in an IoT device. And this effort on software is really important to make sure that we provide the basic building blocks also on the software side. Because it's great to have an encryption engine in your design, a TRNG, etc. That's useful for implementing security. But if you don't do the software right, if you don't partition it correctly and make sure that the non-secure, untrusted software is really isolated from the other functions that are critical in your device, then you lose all the effect on the potential for security in your device. So this element that we call TFM, so Trusted Firmware-M, is one element of PSA, so the Platform Security Architecture. And this consists of open source software that is handling really the low-level tasks for security, like key storage or crypto management, etc., etc. And these elements are provided to take advantage of the hardware features that we have in the subsystem I've shown earlier. They take advantage of TrustZone, they take advantage of the crypto elements that can be put in the system, etc. And this software, you can go right now to trustedfirmware.org. This firmware is open source. It's still in development. We have released the first version, but it's still in development. We have other elements that will come in the future. So we started with the critical parts, but we are continuing development of this code. And we, of course, encourage others to participate. It's an open source initiative. It's not only controlled by ARM, but we encourage others to participate. And that's why we think it's interesting to have collaborations with academics as well, because right now the other partners who participate in this initiative are mostly industrial partners. We think it's interesting to have people who are really interested in security to take part in this effort, because that's really a foundation that can be applied in any case. And this TFM is supposed to be the layer below any kind of RTOS that you can deploy on your system. So of course, on our side, we have EmbedOS. We pre-integrate it with EmbedOS, but there are plenty of other RTOS that are used in IoT devices, and that can benefit from that because the OS, as you see, is on the non-trusted side, non-secure side. So the OS can call these APIs and benefit from this software. So now let's talk about the Musca test chip program, because it's still the topic of the presentation, and explain what we want to do with this program. In fact, so you've seen we have developed systems, and the subsystems are products that we sell to our partners. They also are some kind of reference architecture that we want to promote, because we think that the architecture is helping in terms of introducing more security in IoT devices. And to make sure that they are really used by the industry, and to create an ecosystem around that, we have decided to also allow other companies, other people to use this architecture and to do something useful with them. And so it's not just to demonstrate that, yes, we can do it. It's also a tool that we distribute to the industry to serve as a reference architecture and to allow software development. Of course, we use it internally to develop software, but externally, we want to make sure that everyone can use it as a development tool. So if we look at the block diagram of the chip, so the chip is this boundary. Basically, it's built around the subsystem. So we really wanted to standardize on that architecture. We put a bunch of interfaces, and that's it. We taped out the chip. We have now the chip available. It's already distributed to companies. So basically, we have these boards, and just, well, to make sure that everyone can afford a board if they are really interested in developing software or doing something around security, we loan them. So we don't sell them. It's a loan, and people just have to justify what they want to do with the board. We also have a soft version of that, if you want, in FPGA. If people want to really design hardware around the subsystem and try to do interesting things, we also have FPGA boards that can be used to build around the subsystem and also build software and hardware together. So that's also another tool that we use internally and that we promote to anyone who would like to work on these security solutions. So I will conclude quickly because I don't want to waste your time. It's clear that we are investing in IoT security, and this is really really something that we try to push because it is important to the success of IoT. If we don't have trust and security in IoT, there's no way we can reach these trillions of devices. It will not happen because people will be afraid of deploying these IoT devices. So we can do whatever, better power consumption, better performance, or anything. If we don't have security, it will not happen. So we have recognized that, and we try to push this message to everyone. We are not alone. We have partnered with many companies to push this message and promote that, make sure that everyone is aware, but also everyone understands what are the best practices, and that's the idea of PSA, and have tools to implement that. And that's the idea behind us providing some hardware elements, but we are not alone. There are plenty of other providers who provide elements. And same for the software. And the interesting thing is that we also pre-integrate hardware, software, and pre-integrate systems to make sure that this is not a bag of bits, but this is a consistent solution, because security is the whole chain, not just one element. So integrating them is a big part of the effort needed to get something secure. Now, what we expect from academics is to get involved, because we think that you have a lot to bring in the world of security, and we would encourage you to contact us to talk about PSA, participate in the specification, because PSA is mostly about how to build security into the systems, not only at the hardware level, but really whole systems from manufacturing to end of life, if you want. And we have tools that I presented. If you flash this, you will get to the page where you can apply to have a loan of a Musca board. we have tools to help in that process, and we would like to discuss and participate with you to this effort to bring security to IoT devices. So that's the end of the talk. Thank you very much, and I'm happy to answer a few questions.
Thanks, Mike. Any questions?
Alex Yaklev, Newcastle University. So question is that do you feel that, or do you expect that there could be some kind of non-traditional vulnerabilities? So you showed 4 different windows in one of the earlier slides.
Yep.
Do you expect, for example, that there could be some sort of attacks by forcing some machine learning on the edge by deliberately subjecting it to some kind of data that will eventually mislead the bigger kind of systems by promoting some learning which is not very healthy?
Okay, you mean polluting the data used by machine learning algorithms?
Kind of tricks. And I'm saying if we had access to code, obviously we can have some kind of teach the if the teacher was sort of not from the cloud, but teacher was on the edge, then the teacher would teach something bad things our device, and then it eventually would propagate to the cloud. But even with data, I suppose you can teach something.
Yeah, that's an interesting question. Currently, we don't have the problem because currently at the edge you only have inference when you have machine learning. So you do all the training offline somewhere else with data that you control. So that's less of an issue right now. It will become an issue when you start to do some training on the edge. I agree. And that will require certainly some level of control and of security, some feedback with probably pre-trained models. That's something we don't yet consider because we don't yet have the problem. But indeed, it may be an issue in the future. Yep.
Thank you. We have time for one more question.
Thanks for the talk. I was wondering, you mentioned many technologies, protections here, so is it all on that board?
Sorry?
Is all the technologies, the protections here in this slide on that board?
No, on the so the Musca test chips right now we have included TrustZone, so that's part of the processors that we have used. The new Cortex M33, they include TrustZone technology. We have included CryptoCell, which is used for well, encryption, but also is used to manage keys, to manage secrets, lifecycle as well. So we have these elements. We don't have anything against physical attacks because that was not our target in this project. Okay. But in the future might happen. Yep.
All right. Thank you.
Thank you. Let's thank Mike again.
Thank you.
Thank you.